Hello everyone, this is Manish from Skillable India, and this is the continuation session of geometric dimensioning and tolerancing. In today's session, we are going to learn about the bonus tolerances. Okay, so bonus tolerance is a very important topic in geometric dimensioning and tolerancing. Okay, so with the help of bonus tolerance, although it is not a part of the ASME by 14.5 2018 or 9 terminology, but this is frequently used into the industry. Okay, so basically bonus tolerance is a very important part, and I will let you know that how we get maximum flexibility in manufacturing. Okay, and with this bonus tolerance we can reduce the cost of the manufacturing and the cost of the inspection at very minimum level. Okay, so this is a very important thing in the geometric dimensioning and tolerancing, and it is a very important concepts also. Okay, so this can reduce the cost significantly in the by using the geometric dimensioning and tolerancing. Okay, to understand the flexibility of manufacturing. Okay, so let us take an example. With the help of we have a regular feature of size over here. So this is the example of a regular feature of size. Okay, so 10 plus minus 2, here we have taken the regular feature of size. Okay, in for the ease of understanding, I have taken a very coarse tolerances, very bigger tolerances. Okay, so it will be make much easier to understand that how we make use of bonus tolerances in flexibility for the flexibility of manufacturing. Okay, so right now we have used over here the straightness tolerance. Okay, so straightness tolerance we have used of 1 mm. Okay, 10 plus minus 2 is the regular feature of size, and the straightness tolerance I have used over here is 1 mm. Okay, so after first of all I will understand the concept of with the definition. In GD&T, bonus tolerance is a modification of a GD&T tolerance that under certain condition increases the tolerance. Okay, so what does this means? Under certain condition increases the tolerance. Okay, in the previous session I have already told you about the maximum material condition and least material condition. Okay, so with the help of maximum material condition and least material condition, we will be getting more tolerance. Okay, that's why we are getting more flexibility in manufacturing, and while assembly the rejection rate of the part will be less. Okay, so that's why in automobile sector where thousands and thousands of parts are need to be assembled with one another, so in that case we need broader tolerances, we need more tolerances to get them assembled. Okay, so hence the term bonus, more specifically when the maximum material condition. Okay, so in this case 10 plus minus 2, what is the maximum material condition? In this case maximum material condition of this shaft is 10. If I am considering, so what is the maximum? It is 12. Okay, so 12 is the maximum material condition, and LMC, least material condition, over here is 8. Okay, so MMC and LMC of this part, MMC is 12 mm and LMC is 8 mm. Okay, so it is written more specifically when the maximum material condition MMC symbol is used to modify the GD&T tolerance. Okay, here GD&T tolerance is 1 mm. So this is the GD&T tolerance, geometric tolerance. Bonus tolerance becomes available. Okay, the MMC modifier implies that the GD&T tolerance can be increased if the manufacturing process can control the related feature of size. Okay, so this is very important that the manufacturing process can they get more room for with the help of tolerances. Okay, so let's say with the next example. Okay, so this is the part drawing. We have part drawing, and this is the condition of after manufacturing. Okay, so after manufacturing, what will be the condition? Okay, So here I have, if I have provided one symbol over here, which is of maximum material condition. Okay. So here, if I have provided the symbol maximum material condition with the straightness. Okay. So whenever we are applying the maximum material condition or least material condition, it is only applicable to a regular feature of size. Okay. We can only provide material condition modifier to a feature of size. To a feature, we cannot provide the material conditions. Okay. Only to the feature of size, we can provide the material condition modifier. Either it's a maximum material condition or a least material condition. Okay. So in this case, if I have given the maximum material condition modifier, so what will be, what we will getting over here is, so after manufacturing, we can end up with a part like this. Okay. Which is manufactured at dia 12 and having, okay, so haven't used the diameter symbol, just you have to consider that in this case also it is a diameter. Okay, so after manufacturing we can end up with a part which is manufactured at dia 12 mm. Okay, it is having, this is the maximum material condition. Okay, I have already told you for this condition mmc is 12 mm and lmc is 8 mm. So this is the maximum material condition. So the part is manufactured at 12 mm. Okay. So the maximum straightness error this part can have is of 1 mm. Okay. So this is the envelope. This is the virtual condition. Okay. What is the virtual condition? We will discuss this virtual condition in a very detailed manner in the coming sessions. Okay. But if I will tell you in one word, virtual condition is the worst case condition that the part can enter into the hole. Okay. So in this case, the worst case condition is, or the virtual condition is the maximum material condition plus the geometric tolerance value. Okay. Which is 12 plus 1, which is 13 mm. Okay. So in this case, the virtual condition or the envelope, this envelope, the virtual condition envelope is of 13 mm. Okay. So the maximum variation this part can have is of 1 mm. If the part is manufactured at maximum material condition, then the maximum straightness error can have is of 1 mm. Okay. Then only the part can enter straightness error, so that the part will be enter into the hole. Okay, or into the envelope. In this condition, this is the virtual condition. So with the help of envelope, we are understanding that this part will enter into the mating part or not. Okay, so with the help of envelopes, we understand this, that this part will be enter into the with the mating part, or with or get assembled with the mating part. Okay, so for this we will get the actual mating envelope. So in this case, this is the actual mating envelope. Actual mating envelope. In this particular case, it is produced at the mmc and with the maximum straightness error. Okay, so the actual mating envelope is created with the virtual condition, which is the maximum material condition plus the geometric tolerance value. Okay, so which is equal to the 13 mm. Now there are multiple possibilities. Okay, let's say this part is not manufactured at 12 mm. This part is manufactured at 8 mm. Okay, let's say this part is manufactured at 8 mm. This size, actual local size of this part at is 8 mm throughout this part. Okay, so what will be this part is manufactured at least material condition, because LMC is a 8 over here. Okay, so now in case we are just understanding that part can manufacture at anywhere between 12 and 8. Okay, so let's say we are taking this example that the part is produced at the least material condition, and cannot have the access band more than 1 mm. Oh, sorry. In this case, it cannot have more than 1 mm because the part is produced at mmc. This is the straightness error should not be more than 1 mm in this case. But this part enter into the virtual condition. Okay, so if this part with the 8 mm will enter into this. So the maximum variation, this is the variation. Okay, if this part is, let's say, 8 mm, so the maximum variation this part can have is 13 minus 8. Okay, so 13 minus 8, we have 5 mm. Okay, so the maximum variation we can have if the part is produced at least material condition is 5 mm. Okay, in the coming slide, I will let you know that how this calculations are being done. So this 5 mm is the bonus tolerance. Okay, so this is the bonus tolerance. How we are getting this? Now, practically speaking, if a part which is produced at its least material condition, and if the straightness error is more than 1 mm, it also reaches until the maximum least material condition, virtual condition, the part can enter into the mating part. Okay, so I have already told you that if the part is manufactured at 8 mm, the maximum variation that part can have is of 5 mm. Okay, because we are having the straightness tolerance is of 1 mm and 4 mm is the variation. Okay, so this is the flexibility we want in manufacturing. Okay, so that the scrap rate can be reduced. How to get this flexibility by using the GD&T in is what we are going to discuss in this chart. Okay, that how we are getting this flexibility. Now, this is the same example. This is the same example. Okay, in this case, maximum material condition is 12 mm. Okay, and the least material condition over here is 8 mm. Okay, with this example. So after manufacturing, we are just understanding. I have already told you. In this case, one of the bonus tolerance is one of the terminology which is not into the standards. I have already told you, but very frequently used into the industry and is called the bonus tolerance. Okay, so bonus tolerance is a potential additional tolerance for geometric tolerance. Okay, now where the MMC and LMC modifier is specified, whenever we are using MMC or let's say LMC modifier. Okay, over here, let's say if we are using I will make another feature control frame over here. So whenever we are using maximum material condition or least material condition modifier, okay, it indicates that the stated geometric tolerance applies when the feature of size is at MMC or LMC size limit. Okay, when the actual mating envelope, this actual mating envelope of the feature of size departs from MMC towards LMC. Okay, when the size of the part, this is the part, when the part departs from MMC towards LMC. Okay, so towards MMC, an increase in the stated tolerance is permitted. Okay, so the tolerance will increase. Okay, if the part is manufactured at 12, then the tolerance we have is of 1 mm because this is the actual mating envelope. Actual mating envelope. Okay, so this is created with the help of the virtual condition. Okay, so 12 plus 1, 13 mm. The part can enter into this envelope if the part is created, let's say, at 12 mm. I have already told you, if 12 mm part is the part is manufactured at 12 mm dia, so we have tolerances of 1 mm. Okay, 1 mm variation only we can have because the maximum size, this is the maximum size. Okay, if this size is manufactured, then only the part will enter into the mating part. With the mating part, it get assembled. Okay, so this is the maximum size we have right now. Okay, so if the part is manufactured at maximum material condition 12 mm, we have straightness error, because if the part will be manufactured at 13 mm, let's say 13 mm part is manufactured, so we require the perfect form. In the rule number 1, we have learned this thing that if the part is manufactured at maximum material condition, when the part with the tolerance, geometric tolerance, so this should be the perfect form, which is very costly or which is impossible to manufacture. Okay, so perfect form is required. So what we are using over here is that the part is not in this, sorry. Okay, so the part we are taking it from the maximum material condition. So this is the maximum material condition. If the part is manufactured at maximum material condition, we have 1 mm of variation or tolerance. We have geometric tolerance we have is of 1 mm. Okay, which is this. Now, similar case, if we are moving towards MMC towards LMC, let's say now the part is manufactured at 11 mm. Okay, so what will be the maximum variation over here we have is, if the part is manufactured at 11 mm, we have the variation is of 2 mm. Okay, so this variation is not now 1 mm, it will become 2 mm. Okay, so geometric tolerance value will be 2 mm. So we get more tolerance. Okay, as we are moving towards from MMC towards LMC, from maximum material condition towards least material condition, because in this case, sorry, in this case, we have provided the maximum material condition modifier. So this is the maximum MMC modifier we have used. Okay, so that's why we are moving MMC towards LMC. So this is the 2 mm variation we have. This is the bonus tolerance. Okay. Now, if the part is manufactured, let's say, if the part is manufactured at 10 mm. Okay. If the part is manufactured at 10 mm, dia 10 mm, so we have the we have the tolerance of 3 mm. So this variation will be now 3 mm. Okay. So this variation can become 3 mm and the tolerance value will be 3 over here. Okay. Now, if the part is manufactured at 9 mm, this 9 mm, so this tolerance, this variation can have 4 mm. Okay. So this will manufactured like this. And we have more practical tolerance over here. Still the part will enter into the envelope. Okay. So the maximum variation is of 4 mm. Let's consider. Okay. If the part is manufactured at least material condition, if which is 8. Okay. So this is the maximum material condition and this is the least material condition. Okay, so when the part is produced at 8 mm, so the maximum variation, although if I am considering this, okay, so again the part is manufactured with 8 mm. Okay, so the maximum variation what the part can have is the maximum tolerance. Okay, which is 5 mm. Okay, so 5 mm of bonus tolerance. With the bonus tolerance we have. So as we are moving from MMC towards LMC, we are getting more and more tolerance. Okay, so that's why we use these material condition modifiers in the feature control frame. Okay, and this is very very important to learn that why we are using these modifier and how did we get the more tolerance with this. Okay, so the MMC over here is, I have already told you that whenever we are moving from MMC towards LMC, we are getting more and more tolerance. More tolerance. Okay. Just for the, I have taken very big tolerances just to get understand, just to tell you that how we get the more tolerances. Okay. Now, if I consider one some points if we remember, so in bonus tolerance occurs only when the geometric tolerance is applied at MMC or LMC to a feature of size. Okay, so it is very important point. These are points to remember. Okay, points to remember. Bonus tolerance occurs only when the geometric tolerance is applied to a at maximum material condition or least material condition to a feature of size. So bonus tolerance will only come into effect when we have given the material condition modifier to a feature of size. Okay. Bonus tolerance never get applied when we have provided the tolerance to a feature. Okay. So a feature of size and feature are two different things. Okay. So I've already discussed it before in the discussion that whenever we are applying the maximum material condition or the minimum material condition to in a feature control frame, we get the bonus tolerance. Okay. So this is only applied to a feature of size. Whenever we are applying the material condition modifiers to a feature of size, then we get the bonus tolerance. Okay. Second point is bonus tolerance does not affect the size tolerance. Okay. So bonus tolerance does not affect the size tolerance. Whatever be the size tolerance, let's say it can be a plus minus 0.5, plus minus 0.1. Okay. So it does not affect the size tolerance. 10 plus minus 0.5 or 10 plus minus 0.2. Anything can be that size dimension. Okay. Size tolerance. So it does not affect the size tolerance. Bonus tolerance. Okay. What is the bonus tolerance? If we understand this, so it is the difference between the actual size and the MMC or LMC. Okay. So with the actual size, with the and LMC and MMC. Okay. So the maximum amount of bonus tolerance is permissible. Maximum, if I write it down, so maximum amount of the bonus tolerance permissible is equal to the difference between MMC and LMC. Okay, so we are moving from MMC towards LMC of the actual meeting envelope. Actual meeting envelope of the tolerance feature of size. Okay, so this is very important that it is basically the difference between of that. Okay, whenever we are moving from MMC maximum material condition to a least material condition modifier. Okay. Now, I have already told you this thing that bonus tolerance is applicable to the geometric tolerance applied to a feature of size. Okay. So bonus tolerance is applicable to a geometric tolerance applied to a feature of size FOS at maximum material condition and least material condition. Okay. Now one thing is important. Every dimension is every time we have been provide the tolerance to a feature of size. Okay. So out of 14 geometric symbols, there are total 14 geometric characteristic symbols, out of which we have only these symbols, okay, which can be provided to a feature of size. Okay, which geometric tolerance applied to a feature of size. So these are the only tolerances which we apply to a geometric tolerance applied to a feature of size. Okay, rest of them applied to a feature, and in this also there are some of them we are applying to the feature. I will let you know. Maximum material condition and the least material condition is applied when the geometric tolerance is applied to a feature of size only. Okay, so MMC and LMC modifiers are only applied when the geometric tolerance in the feature control frame is applied to a feature of size only. So these are the tolerances out of 14 that we provide to a feature of size, geometric tolerance to a feature of size, in which it is straightness, flatness, angularity, perpendicularity, parallelism, and position. Okay. So these are the only tolerances. So these are the geometric tolerances which can be applied to a feature of size. Okay, so these are the only geometric tolerance which can be applied to a feature of size with MMC, and LMC modifier. Okay, in this, these are the only geometric tolerances which can be applied to a feature of size. Okay, and get additional tolerance in the form of bonus tolerance, which we called as bonus tolerance. Okay, now there are other tolerances are also there. Okay, so bonus tolerances is not applicable to the geometric tolerances applied to a feature. Now you can see that bonus tolerances is not applicable or to geometric tolerances applied to a feature. Okay, so whenever we are providing the geometric tolerance to a feature, means either surface or hole. Okay, we are providing the geometric tolerance to a feature, so the MMC, material condition modifiers, either it's a maximum material condition or least material condition, both are not applicable. Okay, so these are 13 symbols. Okay, these 13 symbols, whenever geometric characteristic symbols, these are 13 symbols, when applied to a feature, is not applicable for the bonus tolerances, because we do not apply the material condition modifier. Okay, so in this there are 13 symbols: straightness, flatness, angularity, perpendicularity, parallelism, cylindricity, circularity, concentricity, symmetry, circular runout, total runout, profile of a line, and profile of a surface. Whenever these 13 symbols, 13 geometric characteristic symbols are applied to a feature, I am not talking about feature of size, only feature. Whenever applied to a feature, the material condition modifier are not applicable. It means we do not get any additional tolerances. We do not get the bonus tolerances for when we apply the geometric characteristic symbol or geometric tolerances to a feature. Okay, so only these are the geometric tolerances applied to a when they are applied to a feature of size, then only the material condition modifier we use. Okay, so this is the total value of the bonus tolerances we get. Okay, so this is all about the bonus tolerances. Okay, so now in the next discussion we are going to learn, or I am going to tell you about the how to calculate with the chart. Okay, and there is one Excel sheet I will also let you know with the help of that how we calculate the bonus tolerances. Okay, so this is all about the today's discussion. Thank you everyone.